Says, how are you? Okay. I think we can start now. Because we have some persons on the group or some persons in class already. Okay? So let us start. Today we would consider another topic. We've dealt with series of topics right from the time we started the live class. So today we will talk about a very, very simple but not to be neglected topic, which is sword. Swords. Sword is seen as a very, very simple topic where most students neglect. But the reality dawns on them when they are given some questions in the exam or as a test. Okay? Now, to start with, you will agree with me that it is easy to obtain the square root of some numbers like 4, square root of 4, square root of 9, square root of 16, square root of 25, and so on and so forth. It is very easy because they are perfect squares. What if we are asked to find the square root of numbers that are not perfect squares? That's a very good question. So this brings us to our subject matter for this module, which is sword. Now let us consider some basic definitions of sword. Okay? Now sword in general are made up of two basic parts. Okay? So for swords, we have the rational part and the irrational part. Okay? Who says? Okay, how are you? Yeah, good evening. I just want to be sure you're with me, okay? Alright, so let's continue. You said? No problem. So far you can hear me and you can see what I'm writing. There is no problem, okay? Alright, so in general, we said that swords are made up of two parts, which are the rational part and the irrational part. And they have a general form like P plus Q root R. You can mute yourself, who says? Okay? Thank you. So, they have forms like P plus Q root R. And I want you to take note that P, Q, and R are rational numbers. They are rational numbers. Okay? So, I'm sure in my first class I discussed the types of numbers. We have rational, integers, and so on and so forth. The basic components of the real number system, actually. So, there's no point going through them since we already have a background knowledge on them. Okay? So, P, Q, and R are rational numbers. And R is not a perfect square. R is not a perfect square. So whenever we have a particular expression or equation, as the case may be, with this particular form, then we say that we are dealing with swords. Right? So it should be noted that P is the rational part. And I said swords are divided into two parts, the rational and the irrational part. So for this form or format, the rational part is P rather, while the irrational part is seen as Q root R. Okay, so these are the irrational parts of the expression. Okay, now since we have these, let us consider some rules governing swords. You know, this word entirely is governed by rules. So in sword also we have some basic rules that govern sword. Okay, so the first rule is the addition rule. addition rule. We have another rule like the subtraction rule. We have the division, as well as the multiplication rule. Okay, so now let us see how these rules relate to one another. In addition rule and subtraction rule, each of the terms to be simplified is first taken and simplified to the lowest form and then added or subtracted based on the arithmetic operation. Now, this might look so cumbersome. Let me bring it down a little so that you understand what I'm trying to say. So if we have something like this, if we have a root b plus, let's say, c root d as the expression to be simplified. Okay. Now, the first thing we are going to do is to check if this term is in its lowest form. If it is not, then our first task is to make sure that a root b is simplified to its lowest form. The same thing will be done to c root d. And if we are lucky that after simplification, the square root of b and the value of root b and the value of root d are the same. If they are the same, then it is very easy. We'll just subtract a root b and c root d arithmetically, and then we'll get our answer. Okay? Now, the next thing I would like you to know also is that if we have the square root of a plus b, this is not equal to the square root of a plus the square root of b. For instance, if I have square root of 9 plus 12, 9 plus 12, okay, let me use 9 plus 16. Is that okay? The square root of 9 plus 16. This would not be equal to the square root of 9 plus the square root of 16. It is not. Okay? The square root of 9 plus 16 is equal to the square root of 25. And square root of 25 is not equal to square root of 9 is 3 plus square root of 16 is 4. So square root of 25, which is 5, is not equal to 2 plus 3 plus 4, which is 7. So based on the addition rule, you have to take note of these. And whatever happens in the addition rule is most likely going to happen in the subtraction rule. So therefore, in the subtraction rule, a square root of a minus b is never going to be equal to the square root of a minus the square root of b, following the same procedure as the addition. Okay. Now, these are the basics you need to know about the addition rule as well as the subtraction rule. Let's consider the multiplication rule. And this is where we have more applications. So, multiplication rule. For the multiplication rule, it states that the resultant of the multiplication of two surds, let's say the square root of p times the square root of q, okay, is equal to the square root of p times q. This is very, very true. Let us say, suppose p is equal to 3 and q is equal to, let's say, 5, alright, is equal to 5. This will be equal, of course, to square root of 3 times the square root of 5. And let us see if it will be equal to this, 3 times 5. Then you will see that this is equal to square root of 15, which is equal to square root of 15. So these are equal. Okay, so this is the way multiplication rule holds. So if we have an expression, let us say we have another expression like p, the expression is p root the square root of p times b. So let's say we have the square root of p times b root q. Okay? Now, for the multiplication rule, just like I said earlier, it's just going to be the square root of p times, okay, let's say we have a root p times b root q. Now, to multiply these together, we'll have to multiply those terms outside the square root by themselves and then multiply the square roots together. For instance, what I'm just trying to say is we have a times b, okay, then times the square root of p times q. So this will give us ab times the square root of p times q. So these are just simple things to play around with or to know about the multiplication rule. Now, later on, we will start solving some problems, so you will see how these are related, okay? So for the division rule, the division of surds can take the general form of, the division of surds can take this general form. We have square root of p over q will be equal to the square root of p all over the square root of q. So if we have something like this, then we can maneuver our way around it to show that square root of p over q will give us the square root of p over q. Alright? Now let us consider some problems to illustrate the basic rules governing surds. The first question here is to simplify the expression below. And what is the expression? The expression is simplify the square root of 80 plus the square root of 20 minus the square root of 45. So plus the square root of 20 minus the square root of 45. You will realize that this problem is a combination of both addition and subtraction rule. So what is the first step here? The first step here, of course, is to look for any way to simplify these three terms as much as possible. And how do we do that? Is to look first for two terms or two factors of the surd such that one of the factors is actually a perfect square. And what do I mean by that? Which two factors can we have? Which two factors of 80 can we have that would make us to have a particular factor which is a perfect square? Of course, you realize that 80 is equal to 16 times 5. Okay? And 16 times 5, if you consider 16 times 5, 16 is a perfect square, so we are good to go. If you consider 20, 20 is equal to 4 times 5. 4 is a perfect square, so we are also good to go. Then 45 is of course equal to 9 times 5. And 9 is a perfect square. So if you insert or substitute these values into our original expression, what do we have? We have that the square root of 16 times 5 plus square root of 4 times 5 minus square root of 9 times 5. So simplifying this further, you will have that this, based on the multiplication rule, we say we have square root of 16 times the square root of 5 plus square root of 4 times the square root of 5 minus square root of 9 times the square root of 5. So square root of 16 is 4. We have 4 root 5 plus 2 root 5 minus 3 root 5. So what next? The next thing is to check. You observe that these parts are the same. So let us come back to what we already know. If we have 2x, let's say we have 2x plus 5x minus 3x. Of course, you realize that this is just like saying 7 minus 3x will give us 4x. So let us assume that root 5 is equal to x in this case. Is that okay? Now, we have 4x plus 2x minus 3x. 4x plus 2x is 6x. Then minus 6x minus 3x is what? Is equal to 3x. So we have 3x. But since we said that x is equal to root 5, then we can also say that this is equivalent to 3 root 5. And this gives us our final answer. Okay? Now this is very, very easy because it is straightforward. Let us consider another question. These have illustrated the addition as well as the subtraction rule. So let us say we are asked to simplify. I'm sure Oses is still with me. Okay, and make sure you're solving this with me so that we'll know that we are on the same page. All right. So the next question is to find the square root of 60 times the square root of 180. So we have square root of 60 times the square root of 180 all over the square root of 75. Now looking at this, we can use two methods to solve this. It's either we multiply the numerators together to get a single factor or a single term and divide it by the denominator, or we use the initial step that was taken in question 1 above, where we would find two factors of 60 in which one is a perfect square and the other is not. But let us just use the straightforward method to do it. So multiplying the numerators together, this will give us the square root of 60 times 180, which is all over the square root of 75. And if we multiply both of them together, we'll have that 60 times 180 is equal to 10800. So we have the square root of 10800 all over the square root of 75. Our next task is to simplify these further. But based on what we have in the division rule, we can say that, okay, let me recall. Remember we said the square root of P over Q is equal to the square root of P all over the square root of Q. Alright? So if you do that, we'll have that this would give us the square root of 10800 all over 75. And if you eventually solve this, if you divide, this will give us the square root of 144. And by now, I am sure you know that 144 is a perfect square, alright, which will always give us 12 as the final answer. I'm sure we are following at this junction. So, building on the knowledge we have and previous knowledge on what we've talked about, we would have to introduce another concept, okay, which is the concept of rationalization. And that is where most students have challenged, okay, the concept of rationalization. What is then rationalization? Way back, we use this term more often. Okay, probably you're eating and your friend just comes in and he says, let's eat now. Let's share the food together. You say, oh, guy, don't shorten my ration. Okay? You're using mathematical terms unknown to you. So that is what we want to talk about now. So what is rationalization? It is simply concerned with the process of removing irrational numbers from the denominator. So when our major task is to remove irrational numbers from our denominator, then we say that what we are doing is rationalization. Irrational numbers, you know what irrational numbers are? Numbers like square root of 3, numbers like square root of 7, numbers like square root of 5, and so on and so forth. So let us simplify this further with some examples. Now, let us say we are asked to rationalize this expression 7. So rationalize 7 root 5. Okay, 7 root 5. Okay, no, 7 over, let us use this, 7 over 5 root 6. Yes, this is more applicable. Okay, 7 over 5 root 6. Remember we said that when we are talking about rationalization, our main focus is to look for a way to remove the irrational part from the denominator. What is the irrational part in this case? The irrational part, of course, is the square root of 6. So, invariably, they're asking you to find a way to remove root 6 from the denominator. Of course, all I just asked to do is to multiply both the numerator and the denominator by the irrational part. Okay, this is very easy. So how do we go about this? So we have 7 over 5 root 6 times root 6 over root 6. Remember that we want to remove root 6 from the expression, from the initial problem. Okay, so if we simplify this, we have 7 root 6 all over 5 root 6 times root 6. So which is equal to 7 root 6 over 5 times root 36. And root 36, of course, is equal to 6. So we have 7 root 6 all over 5 times 6. Of course, this gives us 7 root 6 over 30 as our final answer. Then let's say we have this we can't reduce this to its lowest step. So we have to leave it this way. But let's say we have a denominator such that we can divide 7. Let's say we have a denominator like 7 root 6 over 21. Then of course, this can go here 1 and this goes here 3. So we can have root 6 over 3. But since 7 cannot go in 30, we have to leave it that way as our final answer. Alright, so I'm sure we are still on the same page. It says, are we still on the same page? Okay, now this looks straightforward because the denominator is a single term. Okay, in case we have two terms separated by an arithmetic operation, let's say plus or minus. Okay, now what is the first thing to do? Of course, the first thing to do is to find the conjugate of the denominator and then multiply both the denominator and the numerator by the conjugate. What then is a conjugate? For instance, if we have, so let me introduce what a conjugate is. If we have P plus Q root R as the denominator or as the expression we want to find the conjugate. Okay, the conjugate is simply this same term, but we have to change this to its counterpart, which is minus. So the conjugate of P plus Q root R is P minus Q root R. What if we have S minus P root, let's say M, as our term, as the term we want to find a conjugate? Of course, the conjugate of this will give us S plus P root M. So I'm sure you understand this very well. So let us take an example to illustrate how to rationalize. Okay, so the next question is rationalize this expression 3 over root 5 plus root 2. 3 over root 5 plus root 2. Now, your guess is as good as mine as to the first step to take. Now, I said you look at the numerator and the denominator. But first, our focus will be on the denominator because that is what we are concerned about. Okay. Now, the first thing is to find the conjugate of the denominator. So let us find the conjugate of the denominator, alright, which is square root of 5 plus square root of 2 give us square root of 5 minus square root of 2 as the conjugate of the denominator, alright. So if we have done that, we would now impute it into our question. Okay, how do we do that? This is very simple. So you have 3 over square root of 5 plus square root of 2. Then we multiply both the numerator and the denominator by the conjugate. So which is square root of 5 minus square root of 2 all over square root of 5 minus square root of 2. And after doing that, so dividing them together, we would have 3 into root 5 minus root 2 all over root 5 plus root 2, then root 5 minus root 2. Remember, the reason why we are doing all this is so that we will remove any irrational part from the denominator. Okay? Now, doing that, we have this to be equal to 3 root 5 minus 3 root 2 all over what is, okay, to do this we have square root of 25 minus 5 root 2 plus 5 root 2, then minus, then we have minus square root of 4. And if you do this, you realize that this will cancel out and we are left with, let's still make it a single term. We are left with 3 into root 5 minus root 2 all over root 25 minus root 4. Now, if you're solving for exam purposes, there's no point writing these. It's just like you're wasting more time. Remember, our examinations test how fast we are and how accurate we could be. Okay? So, doing this, we would have, you just jump this step, and come over here. How do you do that? Just multiply the first term by this term and multiply this one by this one because the middle term will cancel out. So there's no point bothering yourself over that. So if you have that, you would have that this is 3 root 5 minus root 2 all over 5 minus 2. And 5 minus 2, of course, is equal to 3. So we have 3 root 5 minus root 2 all over 3. And if you cancel out, you would have this to be equal to square root of 5 minus square root of 2 as our final answer. Okay, I'm sure we have done justice to the concept of rationalization and surds in general. So this is actually the basic thing we need to know about surd. Any other question you see whatsoever in surd is going to be it's just like a modification of what you already have here. And with this, I'll call this class a quit, okay, so that you have enough time to prepare for the next class. Says, yeah, do you have any question before we end the class? Okay, conjugate. Now, I said conjugate is simply, let me take an example. Let me use the same expression I used earlier. If I have P, okay, P plus Q root R. And I'm asked to find the conjugate of these. Alright? What I'm just trying to say is, or my major focus is to change this addition sign to subtraction. That's just the conjugate. Okay? Everything remains the same. So conjugate of P plus Q root R is P minus Q root R. What if we have P minus R root M as the question we want to find the conjugate? Okay? The conjugate of this is to check what is this term here, what is this arithmetic operation? Minus, right? So we'll interchange it with the addition sign, which is what? P plus R root M. So that is what conjugate is. Is that okay? So if you have something like, if you have an expression like, let's say, A plus B root C all over P minus Q root R, and you are asked to simplify this. If you want to simplify this, you can't do this straightforward. Okay? The first step is to find a way, look for any means to eliminate the irrational part in the denominator. What is the irrational part in the denominator? Of course, it is what? Square root of R. So, how do I eliminate these parts? The first thing is just to find the conjugate of the denominator. Our focus, like I said, is not the numerator, but the denominator. So if you want to do that, we would have the conjugate will be equal to what? P plus Q root R. Since I know my conjugate, I would have to multiply both the numerator and the denominator by my conjugate. And how do I do that? Very simple. I'll say multiply by P plus Q root R all over P plus Q root R. Then I'll have to multiply. Multiplying this, we have A plus B root C times P plus Q root R. Then all over, this will be all over P minus Q root R, then P plus Q root R. Then you solve normally and then get your final answer. Okay? I'm sure you understand now. Alright, so we've come to the end of the class on Surds. I would like you to go over as many problems as possible. One of the ways they can manipulate this Surds problem is after giving you a problem. Let's say we have, which problem can I use? Okay, let me use this. 3 plus 5 root 7 all over 4 minus 3 root 11. Okay? He said simplify these in terms of P plus Q root M. Okay? Leave it in terms of P plus Q root M. What I'm just trying to tell you is, anyhow your answer is going to look like, let it be in this form. Is that okay? This is the form we want your answer to look like. Do you understand? I'm not saying you should, probably you can try it, but I just brought this question out from the space. You get, so it might not give you an exact answer. Do you get it? But I just need to illustrate the fact that they might give you a Surds problem and ask you to put it in terms of something, in terms of a particular form. Do you understand? So all what you just have to do is to make sure your answer corresponds to that form you are asked to leave it. Alright? So that is that about that. I'm sure with this we can end the class on this note. If you have questions, of course you know how to reach me via the platform. Just drop the questions on the platform and I'll attend to them as soon as I see them. Alright, so I'll see you later on in our next class where we'll talk about algebraic equations. Okay? We'll talk about everything about algebra and how to attack any problem. Is that understood? So, I would like to say bye.